In this video, we'll show you how to monitor client-side website performance. That is, you'll use real-world, real user experiences in your performance and experience tracking. We'll show you an architecture that you can use with a variety of analytics and performance monitoring tools, but to make our demonstrated use case concrete, we'll use Google's Web Vitals as our example. Let's map out what we're trying to achieve together, and then we'll jump into the Google Cloud Console and an IDE to set up these resources. We start with a very simple static website, which uses Google's Cloud load balancing and cloud storage services. Your website is probably more complex, perhaps with a backend or web frameworks. However, a single file index.html web page will nevertheless allow us to successfully demonstrate the concepts. The concepts that we show you in this video can be built on and built into a wide variety of web application scenarios. To accelerate the demo, I've already set up the baseline website, which includes a domain name and SSL certificate for HTTPS. The new and interesting part is setting up a cloud function that will capture our performance data via API call. From the cloud function, you'll send the data to Cloud PubSub, which will in turn push the data to a BigQuery data warehouse for long-term retention and analytics. What's really nice about this architecture is that everything here is serverless. We don't have a single VM, operating system, or Docker runtime to provision or maintain in this entire architecture. Further, you'll only need about a dozen or so lines of code to get this working. It's very easy to maintain and is relatively low cost. All right, so let's set up some of these systems. We'll start in an IDE environment, and specifically, I'll use a Google Cloud Shell IDE. Here, we have both infrastructure and application level resources. I want to start on this index.html file because it's already set up. Similarly, we're assuming you already have a website that you want to start tracking performance on. If we look at this website in the browser, we'll just see a very simple Hello World page as is reflected in our HTML. Once your website is running, let's go ahead and provision our infrastructure. With the Cloud Shell IDE, we already have CLI utilities like Terraform, so we can apply these Terraform files. When we attempt that provisioning, we may see authentication issues, in which case we'll need to get a different set of credentials. Using a command like this, you can get application default credentials for provisioning. Off video, I'll navigate to this link and copy in the authorization code. Now we can run Terraform apply. In this Terraform provisioning, we have a BigQuery dataset as well as a table. Also, you should notice that the BigQuery table has a pretty flexible schema. We'll load our performance data as a JSON column since the data schemas vary by metric and can have significant nesting. Still, the data will be relatively easy to analyze later. You'll also need a couple permissions which allow PubSub to access the BigQuery table so that it can push the performance data. Next up is a PubSub topic and subscription. This PubSub subscription has a BigQuery config because we're going to be directly sending BigQuery messages from the message queue. No need for ETL tooling or other services. If you're ready, confirm with a yes. This is a good moment to note that if you're running into errors during the provisioning, just make sure that your user has sufficient permissions and that you've enabled the required APIs in your project. For example, you need to have PubSub enabled for the topic and subscription provisioning. Let's quickly check out what we've created in the console. In the PubSub service, you should see that topic and subscription. The subscription delivery type should be write to BigQuery. In BigQuery, you should see that new dataset and table. So we're now making good progress. These three basic website components were already set up before the demo, and now we've set up some of the backend elements. Next, you'll need to add some client-side code that pushes the performance data, and you'll need to set up an API to receive that data. Let's do the Cloud Functions API setup first. Going back to our IDE in this Functions folder, we have our Python code and requirements.txt file. We'll copy all that into a new Cloud Function. So in the Google Cloud Console, we'll create a second generation function and name it Web Vitals. You need to allow unauthenticated invocations so that the API is accessible by your website frontend. You may want to play with these settings, such as the resource allocations and service account, but in our case, these settings will be just fine. Next, you'll bring in your function code. In our case, that'll be for a Python 3.8 environment. I've renamed the entry point for this function, so let's change the default here. You'll also need to paste in your requirements.txt file. Okay, so in our main.py file here, we're creating a PubSub client, which will use our Web Vitals project and Web Vitals topic. We'll sanity check the content size and that the request is valid JSON before publishing the data to our PubSub topic. There's a little bit of additional complexity here around CORE's configuration. These access control headers basically allow our API to be on a different domain than our website itself, in case you prefer that. If you do want that flexibility, you should probably change this allow origin to match your specific web application protocol and domain, like example.com. For demo simplicity's sake, we're accepting any origin here. Once you're ready, deploy that function. With the Cloud function now deployed, we need to use it as a backend in our load balancer so that we have better domain and configuration control. So if I go to our load balancer, you'll see just one backend, which is our cloud storage bucket. We'll click Edit to add another one, and we specifically need a serverless network endpoint group. We deployed our function in US Central 1, and actually we'll find it in the Cloud Run list since we're using second generation cloud functions. Disable CDN caching for now to make your life easy. In the routing rules, you'll need to choose how to expose your API. That could be by domain, like by routing api.notomatic.io. In this case, ensure you have that CORS configuration that we talked about earlier. Alternatively, you could use the same domain as your website and route based on path. So we could go with API v1 Web Vitals. Cloud Functions will respond on any path, so there's no need to reflect this in your Python code. In the Review and Finalize, we can sanity check the configuration and then continue. While that updates, let's modify our index.html so that it includes the script that'll run and push Web Vitals data. I'm getting this script from the Google Chrome Web Vitals GitHub repository, which I'll link in the description of this video along with the demo code. So we're loading the Web Vitals code and then logging cumulative layout shift, first input delay, and largest content paint metrics once they're calculated. However, instead of just echoing the results out to the console, you'll want to change that behavior and instead push the data to the Cloud Functions API endpoint. We'll add that API call logic in an additional function down here. Then we'll change the console print to the API call. Okay, let's go ahead and push that updated index.html file to our website. Let's check that out now in the browser and specifically the development tools. If I go to the Source tab, we can see the new JavaScript. However, notice that we're not actually sending the performance data. That's because Web Vitals only supports Chromium-based browsers like Chrome, Microsoft Edge, or Opera. So let's bring in a Chrome window and retry our test. In the Network tab, we'll see those Web Vitals API calls and the transmitted data. We're seeing both the first input delay and largest contentful paint. Given the nested data structure, you now understand why we're simplifying things with a JSON data type in BigQuery. The data doesn't lend itself well to flat, tabular representation. Let's jump into BigQuery to see the actual storage of this performance data. In the table preview, you can see that data coming in. We're getting client-side, real-world performance metrics, along with some custom fields like hostname and pathname for ease of analysis. Again, this architecture is very portable to varying analytics and performance monitoring scenarios, not just Web Vitals. If you have any questions, please leave them in the comment section of this video. Thank you for watching.